Hello and welcome to Chapter 1, Section 2. Today we're going to talk about angle measures and angle bisectors. But the first thing we're going to learn to do is construct a copy of an angle. Again, we're doing constructions. We're actually going to get out our compass and we are going to figure out how to draw an angle with just a compass and a straight edge. First thing I'm going to do is draw a line that's about parallel to the bottom. Doesn't matter. I have a point X, I'm drawing a line. There's my baseline for my angle. Now, I am going to, starting at the end point, I'm going to put the pointy end on the end point, and I'm going to draw an arc that crosses both of these lines. Not moving my compass, so I know it's still the same width. I'm going to do the same thing here at X, and I'm going to make an arc that goes through both my line and big enough so that it'll cover this line as well. Now I get to move the compass, and I'm going to use this as a measuring point, and I'm going to measure exactly, whoops, I'm going to label, this is going to be T, and this is going to be U. And I'm going to label this point here Y. And I'm going to measure the exact distance from T to U. And then I'm going to measure the exact distance, whoops, keep that Y there, and make an arc. And that is point Z. This width is the same as this width. And it's exactly the same distance from the end point. So now if I take my straight edge and I connect point X to point Z in a ray, then angle YXZ is exactly the same size as angle TSU. And I'm going to get out a protractor and I'm going to make sure. How do I use a protractor correctly? I'm going to make sure that the end point, the vertex, is right in that circle, that little dot in the middle. And I'm going to line up my baseline with this zero here, this line. And I am going to measure, and this comes out, counting up from 0, 10, 20, 30, whoops, 35 degrees, excuse me, it's between 30 and 40. And right in the center and lining up my baseline. And check that out, 35 degrees, just like it's supposed to be. We're going to use a straight edge to draw a ray with an end point X. We're going to place the point of the compass on S and draw an arc that intersects both sides of the angle. And we're going to label points T and U. Then without adjusting the compass, we're going to place the point on X and draw an arc that intersects the ray. And we're going to label that Y. Now we're going to use the compass to measure UT. And we're going to move that point to Y and draw an arc to intersect your new arc, labeling that point Z. And the last thing you do is draw a ray from point X through point Z with a straight edge. Now that you have all the magic information, please pause here to answer reflection questions 1 and 2 and come back when you're done. For number 1, ray XZ would coincide with ray SU. And number 2 is no, you'd need to be able to measure the opening. Next we have naming angles and parts of an angle. So again, we have some vocabulary. An angle is a figure formed by two rays with the same end point. A vertex is the common end point. The sides of the angle are the rays. They are called the sides of an angle. Essentially, you have an angle, and that's measured in degrees. This is a ray, ST, and this is a ray, SU. And the vertex is the common endpoint of both ST and SU. ST is a side, and SU is a side of the angle. There's two different ways to name an angle. You can be very specific and use 3 letters. This is angle, TSU. The middle letter is always the vertex, always, always. The other 2 letters are on either side of it. It doesn't matter what order. Alphabetical is great, but it's not, if you don't do it alphabetically, it's not wrong. Or if this is the only angle there, you could call this angle S. So if we're looking at this angle, I have one side, ray QP. I have another side, ray QR. I have the vertex Q. I could name this angle PQR or an angle RQP, or just angle Q. But can't you name it angle QPR or angle QRP, because that will actually be incorrect. So you've got a little bit to do here. Please walk through B really quickly, naming more angle parts. You have a quick reflection question, and then 2 your turns, numbers 4 and 5. Pause here and come back when you're done. You have an endpoint K. You could call it angle K. You could also call it angle JKL or angle LKJ. But those are the only 2 other possibilities. For the reflection question, yes, there is another name for it. It's angle JKM. Your turn, number 4. Angle number 2 can either be angle AEB or angle BEA. But I can't call it angle E because that indicates too many things. So that doesn't work. These are the only 2 things you can call it. And copying angle BEC should look like. Please let me know if you have any questions or issues with this kind of construction. And we are on to measuring angles. We usually measure angles in degrees. A degree is, there are 360 degrees in a circle. I don't know how they first came up with this because it's not a convenient number at all, but luckily they still haven't made time metric. The measure of an angle is written M angle A, or M for measure of angle PQR. When we are classifying angles, it's the same classifications that you learned as a 4th grader. There are acute angles. We just write them a little differently now. That is between, greater than and less than, okay? 0 degrees is smaller than, the measure of angle A is smaller than 90 degrees. So anything between 0 and 90, but not including them, and it looks smaller than 90 degrees. A right angle, the measure of that angle is exactly 90, and we tend to write it looking like this. An obtuse angle is between 90 and 180 degrees, but does not include them. And an obtuse angle is larger than 90 degrees. It looks like that. And then we have the straight angle, which is exactly 180 degrees. Our first question, use a protractor to draw an angle with a given measure, 53 degrees. So we get out our protractor and we're going to start by drawing a point and a line. We want to make sure that line is larger than half of our protractor, so it's easy to work. We're going to put that point right in that circle, and we're going to line up our line exactly so we don't make a mistake. Now realize that this side counts up from 0, but this side counts down from this 0 over here. So you want to make sure you get the right 53 degrees. I'm counting up from 0, so I want 50, 1, 2, 3. I'm going to go right there. That is 53 degrees. So I'm going to line up that mark and my end point and draw another ray. And I have drawn an angle with 53 degrees. Please pause here and do the same thing. The trick to drawing an angle, an obtuse angle, is to give yourself a little room. I started over here, that's not enough room. So we're going to put that and line it all up nicely. And we're going to go all the way over to 138 degrees, which is right there. And 138 is more than 90, so it makes sense that this is bigger than a right angle. And we draw that. And we want to mark that 53 degrees, and we want to mark that 138 degrees. And if I wanted to check it, like the reflection question asks, then I line it up, and I actually made 139 degrees, and life goes on. And 53 degrees here, that lines up exactly with 53 degrees there. So double checking is always a good thing. Please pause here and try your turn number 7 and 8. So the steps to drawing an angle with a given measure: you're going to use your straight edge to draw ray XY. You're going to place your protractor on point X so that ray XY goes through the 0 degrees. Find 53 degrees from 0, make a mark and label it Z. Use your straight edge to connect endpoint X through point Z if you need those notes. And we're going to look at the reflection questions. Number 6, we would measure the given angle and the constructed angle and use an arc and measure with a compass. Number 7 is 40 degrees and number 8 is 105 degrees. Next, we're going to construct an angle bisector. A bisector is a ray that divides an angle into two with exactly the same measures. So we're going to take an angle and draw a line right through the middle of it. So we've got a postulate that covers this. Postulate 2 is the angle addition postulate. If S is in the middle of angle PQR, then if S is in the middle of PQR, then the measure of PQS plus the measure of SQR equals the measure of PQR. So it's just like this line plus this line equals the whole line thing. This angle plus this angle equals the whole angle. Constructing a bisector, we want to make sure that an angle is exactly cut in half. So we're going to place the compass point on M, and we're going to draw an arc through both sides. And we're going to label them points P and Q. We are going to make our compass be a little bit smaller than PQ, but not smaller than half of it. So we want it just a little bit smaller. And we're going to draw an arc from Q and an arc from P. And do you see how that made an X? I want to identify that point because that point is right in the middle. And when I connect that point with M, I have created an angle bisector.